Fifth grade, getting ready for sixth grade, lesson 3, factor trees. Unlock the problem. Mr. Shu gives this puzzle to his math students. Write 24 as the product of factors that are prime. Remember that a prime number must be greater than 1 and can have only 1 in itself as factors. You can use a diagram called a factor tree to find the factors of a number. Give an example of a number greater than 1 that has only 1 in itself as a factor. So what would that be? 2, what else? 2, 3, 5, 7, and then so on. There's a whole bunch more, right? 11, okay? But basically, 2 only has 1 and 2. 3 only has 1 and 3. 5 only has 1 and 5. 7 only has 1 and 7. 11 only has 1 and 11. What about 31? Yep. Okay, so it can be some larger numbers as well, right? Use a factor tree to find the prime number factors that have a product of 24. So write the number to be factored at the top of the tree. So we write 24 here. Then we also know that 6 times 4 gets us 24. What else gets us 24? 8 times 3, what else? 12 times 2. So there's a whole bunch of different things, but they gave us 6 and 4 as an example. Okay, so then are 4 and 6 prime numbers? No. So they want us to break it down even more. And what they want you to do is when you're breaking these apart, no matter which numbers you first use, you always need to list the smallest one first. Okay, so I said 6 times 4, but is that how I wrote it there? No, I wrote 4 times 6 because I wrote my smaller number first, right? Because then that will help you when you write out your actual factors. Okay, so 4 times 4, what times what would get us 4?
2 times 2.
So 2 times 2, and then 6?
2 times 3.
And then so here is my factors that would go into 24. So 2 times 2 times 2 times 3. Because 2 times 2 is
4.
4 times 2 is 8. 8 times 3 is 24. So 24, the factors of 24 would be 2 times 2 times 2 times 3. Try this. Make a different factor tree for 24. Okay, is the product of factors the same as the example? So you need to do our product tree first, right? Okay, so I heard you guys say 2 times 12. I heard 3 times 8. So let's go ahead and try that. So 3 times 8. Okay. Now, can 3 be broken down any more?
No.
No. Okay. So then we're going to look at 8. What can 8 be?
4 times 2.
What?
4 times 2.
But can I write 4 times 2?
2 times 4.
2 times 4. Okay, so since I couldn't use 3 anymore, I'm going to go ahead and circle that because I am going to be able to put that in my factor series. Okay? Then, can I break 2 times 4 down anymore?
Yeah.
I can break the 4, but can I break the 2?
No.
No. So I'm going to go ahead and circle that because I'm going to use it as well. And then I'm going to break the 4 into
2 times 2.
2 times 2. And then am I going to break those down anymore?
No.
No. So those will also be it. So, did we use the same thing?
Yes.
So, yes, okay, you can use, or it says is the product of factors the same as the example. So, yes, because we still got the factors of 2 times 2 times 2 times 3. So the reason why I had you guys circle these is so you don't forget what you're going to use in your factors, okay? But I circled 3 first. Would that be what I list first? No, because once again, I told you guys to list smallest to greatest, right? Or least to greatest. All right. Sharon, so use a factor tree to find the prime number factors that have a product of 210. Write 210 as the product of any 2 factors. So we're going to write 210 up here. Okay? So anything with a 0 at the end means that it was multiplied by a multiple of 10. And in this case, so we would put 10 here, right? So basically 210, we said was 10 times 21, right? Even when it wants us to write each factor as the product of factors. So 10 could also be what? 2 times 5. So I would put that over here as well. 21 would be
3 times 7.
3 times 7. So I'd write that over here as well. So now each factor has only one in itself as a factor. Basically, they're saying 2 can't be broken down anymore, 5 can't be broken down anymore, 3 can't be broken down anymore, and 7 can't be broken down anymore. Okay? Now, can I rewrite those in that exact order?
No.
No, because are they least to greatest?
No.
No. So what would I say?
2
So,
times 3 times 5 times 7.
and then are those least to greatest?
Yes.
All prime numbers?
Yes.
Yes. So use a factor tree to find the prime number factors. So 8, what can I say?
2 times 4.
2 times 4. Can 2 be broken down anymore?
No.
Nope. Can 4 be broken down anymore?
Yes.
Yes. So what could 4 be broken down into?
2 times 2.
2 times 2. Can those be broken down anymore?
No.
Nope. So our answer would be 2 times 2 times 2. And then I circle my answer. 45. What can I do for that?
9 times 5.
5 times 9. Can 5 be broken down anymore?
No.
Can 9?
No.
Yes. What can 9 be broken into?
3 times 3.
3 times 3. Can those be broken down anymore?
No.
Nope. So I'm going to circle those. So what's my order?
3 times 3 times 5.
3 times 3 times 5. So we have 350. What is something easy we can do there? First of all, we see a 0, so we can say 35 times 10, but can I write it that way? No. 10 times 35. Is 10 a prime number?
Yes.
No. So what would we break it into? 2 times 5. Are those both prime numbers?
Yes.
Yes, so we're going to use those two. 35, is it a prime number?
No.
No. What can I break it into?
5 times 7.
5 times 7. Are those prime numbers?
Yes.
Yes. So I need to do my smallest to largest, right? So 2 times what?
5.
5 times 5 times
7.
7. Alright, so you guys are going to do 5 through 7 with your partners. Go ahead and get started. Problem solving. Mr. Shu gave these problems to his math students. Write 500 as a product of prime factors. Each factor must be greater than 1 and can only have 1 in itself as factors. So what would I underline? 500 and then prime number factors, right? And then over here, I'm going to do my factor tree, right? So 500, what can I break that into, guys? Can I do 5 times 100? So 5 times 100. Is 5 a prime number? Yes. Is 100 a prime number? No. So what can I do for 100? Can I do 5 times 20? Is 5 a prime number? Yep. Is 20? No. What can I break it into?
4 times 5.
4 times 5. Is 4 a prime number?
No.
No. Is 5 a prime number? Yes. So 4 I'm going to break into what?
2 times 2.
2 times 2. Is 2 a prime number?
Yes.
Yes. So I'd circle both of those. So what are my factors?
2 times 2 times 5 times 5 times 5.
So 2 times 2 times 5 times 5 times 5, right?
Yep.
Okay, find a number that has 4 identical even factors. Each factor must be greater than 1 and can only have 1 as its factor as itself. So 4 identical even factors. So, what would be an easy even factor? 2. So I have to write it how many times? 4 times. So 2 times 2 times 2 times 2. And what would those be the factor for? What would those be the factors for? 2 times 2 is
4.
times 4 is, how many times 2 is
8.
8. 8 times 2 is 16.